12-factor app, a term introduced by Heroku co-founder Adam Wiggins in 2011, is a set of principles to create high-quality software that can be easily maintained, scaled, and deployed. A 12-factor app is a way of building software applications that are easy to use, reliable, and can handle lots of people using them at the same time. It's like building a toy that lots of kids can play together without breaking it. The 12-factor app has 12 important things that needs to be considered when building the app, like how to store the app's code safely, how to separate different parts of the app, and how to make sure the app works the same way in different environments. But is it still relevant? How important is it still in today's world? Welcome to Omega Codex, and my name is Sanal. The 12-factor app is organized around 12 key principles, each of which plays a crucial role in building scalable and maintainable applications. Let's try to understand what a 12-factor app is, what makes it relevant today, and most importantly, where it doesn't work. So let's get started. Let me start with a story. Once upon a time, there was a company called Dummy Cop. They had developed a new web application that was gaining a lot of popularity among their customers. However, as the number of users grew, they began to face several challenges. Firstly, their application was tightly coupled, which made it difficult to scale. They needed to add more servers to handle the increased traffic. In those days, deploying an application was a slow and cumbersome process. Developers would have to manually configure the infrastructure and dependencies for the application, which often led to inconsistencies and errors. It would take them several days to configure and deploy the application to new servers. Secondly, managing configurations and secrets became a nightmare. They were storing their configuration files in their codebase, which made it difficult to manage different environments such as development, staging, and production. Thirdly, debugging issues in their application was a time-consuming task. They had to log into different servers to check logs and troubleshoot issues, which made it difficult to pinpoint the root cause of the problem. The lack of standardized approach to building and deploying applications made it difficult for them to work together. To solve these problems, Dummy Cop began to research best practices for developing scalable, maintainable web applications. In came the 12-factor app, a methodology which provided a set of guidelines for building modern cloud-native applications. But what are these guidelines and principles? The first principle is codebase, which is probably the easiest one. It states that a codebase should be stored in a version control system, such as Git, and that it should be a single code base per application. But how can we apply this principle? The single code base stored in version control system contains all the code necessary to run the application. It ensures that there is a single source of truth and makes it easier to manage and deploy the application. The code should be organized into branches such as master or development, allowing different versions of code to be developed and tested in isolation. All dependencies such as libraries and frameworks should be declared in the code base rather than being installed globally on the system. The second principle is dependencies. It states that an application's dependency should be explicitly declared and isolated from the application itself. What does that mean? Well, all dependencies such as libraries and frameworks should be explicitly declared in a manifest file such as a package.json in Node.js application or a project file in .NET App. These dependencies should be isolated from the application itself so that the changes to the system or application does not affect the dependencies of the application. Dependencies should be resolved by a dependency management tool such as npm, NuGet, or pip to ensure that the correct version of the dependency is installed. This principle ensures that an application is self-contained and can be easily managed and deployed. Third principle is configuration. It states that an application's configuration should be stored in environment rather than being hard-coded in the application, which was being done by our Dummy Cop story. What does it imply? Configuration variables such as database, credentials, or API keys should be stored in environment variables rather than being hard-coded in the application. These should be separated from code so that changes to the configuration can be done without changing any code in the application. It should be consistent across different environments such as development, testing, and production to ensure that the application behaves consistently across different environments. This ensures that the application is configurable, portable, and can be easily deployed to different environments. The fourth principle is backing services. It states that an application should treat backing services such as databases or message queues as attached resources that can be attached or detached without affecting the application's behavior. Here are some of the examples of how to apply this principle. An application should connect to backing services through a URL or a configuration variable rather than hard coding the connection details into the application code. The application should use a standard interface such as a database driver or a message queue library for accessing backing services to ensure that the application can be easily switched between different backing services. Again, this ensures that the application is portable, scalable, and can be easily integrated with other services. The fifth principle is build, release, and run. It is about separating the stages of building, releasing, and running your application, and making sure that each stage is isolated and well defined. When you're building your application, it should be just about transforming the application code into an executable build. It should work on all your environments provided the configuration is applied when deploying it. Once you have built your application, you need to release it to the people who will be using it. To do this, you want to make sure that your release process is well defined and repeatable. This would involve combining the build with required configurations, running automated testing tools, and is ready for immediate execution. Once your application is released, it needs to run on different computers or servers. This means that the app should be deployed to a specific server or cluster of servers, and that the runtime environment should be well defined and repeatable. By separating the building, releasing, and running stages of your app, you can also make your app more scalable. This means that you can easily add more resources like servers or processing power to the runtime environment as needed, without affecting the development and release stages. This principle makes sure that your application is built, released, and run in a well-defined manner, making your app more reliable, scalable, and easier to maintain over a period of time. By the way, when you subscribe to the channel, it motivates me to build, release, and run more videos on this channel. So go ahead and click that subscribe button. It's completely free for you, but priceless for me. The sixth principle is processes, or execute the app as one or more stateless processes. This is about designing your application stateless, which makes it easy to scale and deploy across multiple servers or containers. When an application is stateless, it means that it does not rely on the state of a specific server or container to function. For example, a web application might use a load balancer to distribute requests across multiple servers. Each server can handle requests independently without relying on the state of other servers. This makes it easier to scale the application horizontally by adding more servers to the cluster. Also, by separating your application into multiple stateless processes, you can separate different concerns of the application. For example, you might have one process that handles user authentication, another that handles payment processing, and another that serves web pages to the users. This makes it easier to manage different parts of the application and make it more flexible. Each process being stateless and independent makes it easy to replicate across multiple servers or containers, and it's easy to scale the application horizontally as needed. If one process fails, it doesn't affect the other processes in the application, making the application fault tolerant, which can handle failures gracefully. Stateless processes also use resources more efficiently because they don't rely on the state of the specific server or container, which means resources are used more effectively and it reduces the overall cost of running the application. The seventh principle is port binding. It states that an application should expose its services through a port binding mechanism and not by binding to a specific network interface. This makes it easier to deploy the application across multiple environments without worrying about the underlying network topology. Sounds confusing? Let me explain. A web application can expose its services by binding to a specific port, which can be configured at the runtime. For example, Node.js application can use the process.env.port environment variable to bind to the port provided by the hosting environment. The database services can be exposed via a port binding mechanism, which allows clients to connect to the service using a standard database protocol. For example, a SQL server can be configured to listen on a specific port, and the clients can connect to the server using this port. Message queues can also be exposed via port binding mechanism. For example, RabbitMQ can be configured to listen to a specific port, and clients can connect to the queue using the AMQP port protocol. This means that an application should listen to a specific network port for incoming request and should not assume that a specific port is available or will remain available. Instead, the application should explicitly declare the port it will use for communication, and the port should be configurable through environment variables or other configuration mechanisms. By explicitly declaring the port they use for communication, the applications can be easily deployed to different environments without requiring the changes to the application code. This also enables application to be scaled horizontally by running multiple instances of the application on different machines or containers, each listening to a different port. The eighth principle is concurrency. It states that an application should be able to scale horizontally by running multiple processes or threads to handle concurrent requests. Web servers can handle multiple requests concurrently by running multiple worker processes or threads. Applications that perform long-running background jobs can use job queues to handle multiple jobs concurrently. The use of asynchronous programming techniques and multi-threading can also help with concurrency. Application connecting to a database should use connection pools to handle multiple concurrent database connections. Through this principle, the application can take full advantage of modern hardware and infrastructure to maximize its performance and availability. The ninth principle is disposability. It states that an application should be designed to start up quickly and shut down gracefully without losing data or state. Containerization technologies like Docker allow you to create lightweight disposable containers that can be started and stopped quickly. This makes it easier to deploy and scale applications. Applications that are designed to be stateless, with all states stored in database or external storages, can easily be disposed and recreated. This makes it easier to scale the application horizontally and recover from failures. The applications designed to shut down gracefully allow them to finish the process, any in-flight requests and jobs before exiting. For example, a web server can use a graceful shutdown mechanism to stop accepting new connections and finish the processing of any outstanding request before shutting down. The 10th principle is dev-prod parity. It states that the development, staging and production environments should be as similar as possible to minimize the risk of bugs or errors caused by differences between environments. One way to achieve this would be containerization, which allows you to package the application and its dependencies into a single container image that can be deployed across different environments, ensuring consistency between environments. Infrastructure as code using tools such as Terraform can be used so that the same infrastructure can be easily replicated across different environments. By ensuring that the development environment is similar to the production environment, you can catch bugs and errors earlier in development process, which can save time and resources. The 11th principle is logs. It states that an application should produce logs as event streams and treat them as data, allowing them to be easily aggregated, filtered, and analyzed. Logs should be produced in a standard format, such as JSON or syslogs, to ensure that they can be easily parsed and analyzed. Logs should be aggregated in a centralized location, such as an ELK stack, so that they can be easily searched, filtered, and analyzed. Logs should be produced at different levels, such as debug, info, warning, and error, to provide different levels of detail for different scenarios. It is essential for monitoring and troubleshooting the application, and it can help you identify and address issues before they become serious problems. The 12th principle is admin processes. It states that administrative tasks such as database migration or restarting processes should be automated and run off as one process rather than being run manually. Database migration should be automated and run as a process so that it ensures that the migrations are consistent across different environments and reduces the risk of human error. Processes should be designed to be stateless, as I mentioned earlier, so that it can be easily restarted without losing important data or state. Also, restarting it should be an automated and run as one-off processes. Also, disaster recovery processes should be automated and tested regularly to ensure that the application can be quickly recovered in case of a disaster. This is essential for ensuring the reliability and availability of the application, and it can help you avoid costly downtimes and data loss. Phew, quite an exhaustive list, right? But if you analyze carefully each principle, there isn't anything magical here. These simple rules help us manage our applications better as it becomes bigger. There are several successful applications that have been built using the 12-factor app methodology. Here are a few names. Netflix is a leading video streaming service that we all love that has been built using the 12-factor app methodology. Based on the 12-factor app principles, its microservice architecture has enabled the company to scale its platform to millions of users worldwide while maintaining high reliability and performance. Shopify is a popular e-commerce platform that has been built using the 12-factor app methodology. The platform's use of 12-factor app principles has enabled it to scale to thousands of merchants and customers worldwide. Twilio, another example, is a cloud communication platform that provides developers with tools and build and manage communication applications. It is built using 12-factor app methodology, which has enabled the company to scale its platform to millions of users worldwide while maintaining high levels of reliability and performance. What makes it significant in today's world is that it focuses on building more secure, agile, and scalable cloud-native applications that can be easily deployed and managed across different environments. Following these principles, developers can build applications that are optimized for the cloud and that can be easily deployed and managed in different environments. Applications become more agile and scalable, enabling them to rapidly respond to changing business needs and market conditions. You also reduce the risk of security breaches and minimize the impact of security incidents. Teams can work more efficiently and effectively. It also emphasizes the use of containerization, which makes applications more portable across different cloud platforms. This can be particularly useful for organizations that need to deploy applications in a multi-cloud environment for redundancy or geographical distribution. Of course, it's important to remember that the 12-factor app is not a one-size-fits-all solution. There are some cases where it might not be the best fit for your application, and it could be more challenging to implement the principles. For example, if you are working with a legacy system, it might be more challenging to implement the 12-factor app principles. Many legacy applications are monolithic, meaning that they are tightly coupled systems with many interdependencies. These applications can be difficult to scale and maintain, as any change to one part of the system can affect the entire application. Applications that have complex deployment processes such as manual deployments or custom scripts can be difficult to scale and maintain, as each deployment may require a significant amount of time and effort. Implementing these principles can seem to be overwhelming, but you can look for few points which can help you get started. For example, any runtime configurations should be stored in environment variables such as database connections, API keys, or other sensitive information. Storing configuration in code or file system introduces complexity and makes it harder to manage. Is your application mixing the application logic with infrastructure and deployment concerns. Each of these factors should have clear separation of concerns, making it easier to manage, deploy, and scale. Does your application include application dependencies in the code base? It will make it harder to manage and deploy changes. Instead, the application should rely on package managers such as npm, NuGet, or pip to manage the dependencies. Are you using centralized logging? Logging and monitoring are critical to understanding the health and performance of your application. Without a centralized system, it can be difficult to debug issues and monitor performance. Are the deployments automated? Deploying an application manually can be time-consuming and error-prone. Automating deployments using tools such as Azure DevOps or Jenkins can help you reduce errors and improve the deployment speed. Are you performing continuous integration and testing? Continuous integration and testing can help you catch bugs early in the development process, reducing the time and cost for fixing issues later. Without continuous integration and testing, it can be difficult to catch issues before they make it into production. These quick wins can help you set on a path for implementing all the principles for a 12-factor app. Over the years, the 12-factor app methodology has become highly relevant because it provides a set of best practices for building modern cloud-native applications that can scale and evolve with the rapidly changing technology landscape. As business increasingly adopts cloud technologies, there is a growing need for applications that can be easily deployed and managed in different environments. This methodology provides a standardized approach for building such applications, which can be deployed and managed across different cloud platforms. Furthermore, the 12-factor app methodology emphasizes the use of modern software development practices such as continuous delivery, containerization, and infrastructure as code. By adopting these practices, organizations can build applications that are more agile, scalable, secure, efficient, and resilient, enabling them to rapidly respond to changing business needs and market conditions. By the way, we have our dummy corp who found out about 12-factor app and have been working on it to implement. Hope you didn't forget about them. Wouldn't it be bad if they didn't have a happy ending? Well, by following the 12-factor app methodology, Dummy Corp was able to break down their application into smaller independent services, which made it easier to scale and deploy. They also began using environment variables to manage configuration, which made it easier to manage different environments and secrets. Additionally, they implemented centralized logging and monitoring, which helped them quickly identify and fix issues. They also started automating their deployments, which reduced the risk and errors and improved the speed of their deployment process. With these changes, Dummy Corp was able to build a scalable, maintainable, and a cloud-native web application that was easy to manage and deploy. Their customers were delighted with the improved performance, and the company was able to focus on developing new features rather than spending time on maintenance and debugging. That does have a happy ending, right? I hope this video gave you a good understanding of the principles of 12-factor app. I'm sure you must be already applying some of these principles, but incorporating all of them can obviously get you more benefits. Let me know your thoughts and feedback in the comment section below. If you want to know about which .NET platform to use on Docker, you can check this video here. If you are looking to improve your source code management and want to know more about Git branching strategies, check out this video here. Thanks for watching. See you in the next one. Till then, adios.